This is 1.4, solving absolute value functions, day 2. So on day 1, we talked about how to solve absolute value functions where there was one absolute value. And today we're going to add a little bit of an extra aspect to it, see where there are 2 absolute values. So it's going to be the same kind of concept where we're still going to write and solve 2 of the equations. We set one side of the absolute value equal to the inside of the other and the negative of the inside of the other. So we'll see what that means here in a minute. But one note is that it's super important to check your work or check your answer before to see if it works. So we have what's called an extraneous solution, and if we look in the word extraneous, we see extra. That means it's an extra answer that mathematically, like when we solve it, it's fine, but when we plug it back into the original, it does not work. So that's technically not a solution. So let's see what this looks like. All right, first one. We have the absolute value of 3x minus 4 is equal to the absolute value of x. So we have, both sides are actually absolute values by themselves, so we can just pick which one we want first. To simplify, I'm going to pick the left side, so I'm going to take the absolute values away from that one, and I'm going to write it twice. So 3x minus 4 and 3x minus 4. And then I'm going to take what's on the inside of the second one, and I'm going to rewrite it for the first one, and then make the negative version of it for the second one. Now, just like we did yesterday, we're just going to solve the 2 equations. So I'm going to subtract 3x from both sides. Negative 4 is equal to negative 2x. Divided by negative 2. So we get that x equals positive 2. Same thing on this equation, subtract 3x. So negative 4 equals negative 4x. Divide by negative 4. And we have 1 equals x. Like we did yesterday, we're going to substitute back into our original. Now we're just probably going to have more than one place to do it. So looking at the first answer, 3 times 2 is 6. 6 minus 4 is 2. Absolute value is 2. So I have 2 equals, and then on the right side, absolute value of 2 is 2. So this one worked out. Awesome. Next one, 3 times 1 is 3, minus 4 is negative 1. The absolute value of negative 1 is 1. And then on the other side, the absolute value of 1 is also 1. So this one worked out as well. So we have those 2 solutions. All right, let's maybe make it a little bit harder. Once I get everything erased, which has taken a little bit longer than I thought. All right, so the next one. We have the absolute value of 4x minus 10 equals 2 times the absolute value of 3x plus 1. We have one side where we just have an absolute value, so we're going to take what's in that absolute value and write it twice. 4x minus 10 equals, and 4x minus 10 equals. For the first equation, I'm just going to rewrite the right side, except switch the absolute value to parentheses. And then I'm going to do the same thing for the second one, but I'm going to throw a negative in front. So negative 2 times the quantity 3x plus 1. So solving it, we need to distribute first. So 4x minus 10 is equal to 6x plus 2. I'm going to subtract 4x from both sides. So negative 10 equals 2x plus 2. Subtract 2. Negative 12 equals 2x. Divide by 2. And we get negative 6 equals x. Same process over here. 4x minus 10 equals negative 6x minus 2. I like my x's to be positive, so I'm going to add 6x. If you want to move the x's to the right side, that's okay too. I just like positive numbers. So 10x minus 10 equals negative 2. Add 10 to both sides. 10x equals positive 8. So when we divide by 10, I'm going to reduce that to be x equals 4/5. So we're going to plug back into our original. 4 times negative 6 is negative 24 minus 10 is negative 34. Absolute value is 34. All right, negative 6 times 3 is negative 18, plus 1 is negative 17. Absolute value is positive 17, times 2 is 34. So this one worked out for us. All right, on the other side, 4/5 times 3 is 12/5. Plus 1 gives us, oh, I'm on the right side, sorry. 12/5 plus 1 equals 17/5. Absolute value is 17/5 times 2 is 34/5. Sorry, I went backwards on that one. I was thinking ahead. On the left side, 4 times 4/5 is going to be 16/5 minus 10 is going to be negative 34/5. Absolute value is still 34/5, so that one works as well. So we still have two answers. All right. Last but not least. All right, here we go. Last but not least, we have the absolute value of x plus 5 equals the absolute value of x plus 11. So both sides are solved for an absolute value. I'm going to pick the left side, so I'm going to write that twice, x plus 5, and then x plus 5. I'm going to rewrite what's inside. I'm going to change, actually, the easiest way to think about it is change the absolute value bars to parentheses, so x plus 11, and then rewrite that x plus 11 in parentheses, and then I'm going to throw that negative up in front. So left one, we can kind of ignore those parentheses, right, because when it's a positive on the outside, it doesn't actually mean anything. So I'm going to subtract x to get rid of this one, subtract x. And I get 5 equals 11. So we found in a previous lesson that if we get 5 equals 11, then that means we have no solution here. So this side has no solution. Let's see if the other side does. This negative out front is like a -1, so I'm going to distribute. Get x plus 5 equals negative x minus 11. I'm going to add x to both sides, again, because I like it positive. 2x plus 5 equals negative 11. I'm going to subtract 5. 2x equals negative 16. Divide by 2. X equals negative 8. Now let's see if it works. Negative 8 plus 5 is negative 3. Absolute value is 3. And negative 8 plus 11 is positive 3, and the absolute value of that is also 3. So we only have one solution here. So again, follow the same protocol. The easiest thing I would say is to turn your absolute value bars into parentheses and then make sure on one of them you just throw a negative in front.